Okay, everyone, hello, I'm back. And where we left off was with the recessive abnormal genes on the X. So now we're going to move on with autosomal dominant. Affected persons have an affected parent, but it only has to be one because it's not recessive. Affected persons mating with normal persons have affected and unaffected offspring in equal proportions. Males and females equal because it's not anything associated with the X-linked diseases. And example of an autosomal dominant that's more common than we'd like it to be is Huntington disease. It's progressive dementia and worsening of uncontrollable movements of the limbs. So basically, it's a neurological disorder. And symptoms start after 40 years old. Autosomal recessive, again, is going to be with the somatic cells, but you have to have both parents have to carry it because it's a recessive gene. So, and here it is, must have two of the affected genes for it to be expressed. The trait usually appears in siblings only, not in the parents, simply because the parents would have had it by now. You don't get this later on in life. It's something that you're usually born with, such as Tay-Sachs disease and cystic fibrosis. Males and females equally likely to be affected, again, because it's autosomal, it's that cell. For parents of one affected child, the recurrence risk is 1 in 4 for every subsequent birth. Both parents of an affected child carry the recessive allele, and they usually don't know it until it expresses itself in a child. I have a very good friend who is an identical twin. I knew both her and her husband in high school. They're both attorneys now. And anyway, my friend Patty was an identical twin, and she was one of 4 children and the first one to have kids. So nobody knew it hadn't expressed itself yet, that they even carried the gene for cystic fibrosis. And here she had twins herself, but not identical. They were fraternal, and that was actually in their favor that they weren't identical. They did not have the identical genotype. And she had a boy and a girl, and her son Billy had the cystic fibrosis. So there you have it. Parents of the affected child may be blood relatives. Again, why is it lining up? For example, first cousins. And here's the example of cystic fibrosis. It's a defective transport of the chloride ion. And the chloride ion leads to salt imbalance that results in secretions of thick, dehydrated mucus. When you have a salt imbalance, you can have very, very waterfall of salt. So very thick. It needs more water in the mucus. It's very thick, dehydrated mucus. And you say, well, so what? Well, the so what factor is our lungs are lined with the mucus blanket. And if it's super thick, they get pneumonias. They get all kinds of respiratory ailments to the point where it can kill them. Also, the digestive organs, and especially the pancreas, it becomes obstructed with mucus because, again, they've got all this mucus. It's not normal like yours and mine, leading to malnutrition. And a lot of the pancreatic enzymes, they take buckets of enzymes to keep themselves normal, are not utilized because of this disorder. Lung areas become clogged with mucus, and again, a lot of them die from respiratory problems. Okay. For genetic diseases, period, let's talk about what a mutation is. What does that mean? A mutation is the changing of the structure of a gene. So it can be deleted, it can be an extra insertion, or rearrangement of larger sections of the genes or chromosomes. And in doing that, because it's rearranged, it can happen because of old DNA, or it can become sticky, and it sticks together on that rung of DNA. So greater chance of Downs, especially after the mother is 38 years old. Down syndrome is trisomy 21. They have 3 copies of one chromosome in one cell, and they're not supposed to have 3 copies. It's a somatic cell that does not contain a multiple of 23. Like we said, all somatic cells have 23. And the 21st chromosome has 3 copies of it, and that's where we get our Down syndrome babies. Less than 38 years old, the mom, there's a 1% chance of having this trisomy 21. After 38, it's up to 8 to 9% chance. And those are simply statistics. I've been doing this a really long time, over 28 years, and I've seen downs at 32 years old, 33 years old, 18, 19 years old. So it doesn't have to be this, but statistics aren't right or wrong. They just are. Mutations occur more frequently in cells that are most actively dividing, such as epithelial cells. Cancer cells divide faster, so is more affected by chemotherapy and radiation. And Down syndrome, how those the people look, or the babies look, they're cognitively disabled, mentally disabled. They have a nasal bridge is very low or flat, and that's why their eyes look like they're fairly wide apart. Very poor muscle tone. A lot of times they'll have a protruding tongue. Most of us, if we're just sitting, our tongue stays in our mouth. Their tongue may come out. They have a fold of the upper eyelid. They call it an epicanthal fold. Yeah, that's about it. A lot of them can have heart defects too. Okay, Turner syndrome belongs to females. It's got a genotype of 45X, so it's missing the 46th chromosome. There it is, missing a sex chromosome. And because it's missing that X chromosome, a lot of the girls are born with an absence of ovaries. They have underdeveloped breasts, wide nipples, and this X is usually inherited from the mother. They have redundant neck skin, peripheral lymphedema in newborns, meaning lymph is everywhere, so they have a lot of edema in the body. Short stature when grown, and that's about it on that one. And then the Klinefelter syndrome we find in males. It's got the X and the Y, but it's got an extra X. So unlike Turner's, it's got an extra one instead of missing one. And a common cause of infertility in men, they have small testes, sparse body hair, long limbs, and with sparse body hair with female distribution. I do have some pictures of both Turner's and Klinefelter's on our titanium site, and they'll have hair in areas where females, like in the pubic area. They can have moderate mental impairment, whereas Turner's has no mental impairment. Okay, let's talk for a minute about multifactorial inheritance. And what that means is many factors are involved. So it's combined with environmental influences. And a really good example would be height and IQ. And the reason I say height is because if somebody is malnourished because of where they were born or how they're fed, they may live in a car, they may not, have proper lodging and food. So the long bones aren't going to grow like they should be. So they could have a genotype that, they should be 6 feet tall, but because of the multi-factors in their environment, they may end up being 5'6", 5'7", even shorter. IQ, same thing. If we do not, have the proper nutrition, and again, I'm going to push breastfeeding all the way. It's the perfect food as babies. That helps brain development, helps with neurological development. Things listed here, such as radiation, tobacco, asbestos, all cause cancer and can definitely mutate cells that were born normally, should be normal. Again, multi-factors involved. Immunosuppressants, if we take enough of those and their body is immunosuppressed, they can have autoimmune disorders and many, many diseases. Rheumatoid arthritis, a lot of arthritis cancer is looked at as an autoimmune disorder now. And then viruses can definitely distort and mutate cells. So basically what this slide is saying is that not all traits are produced by single genes. Some traits result from several genes acting together. And so we call those polygenic traits, poly meaning a lot. This is when environmental factors influence the expression of a trait. Better nutrition, better learning environments for our children. Another example I thought of are flamingos. Those are really, really pretty pink birds. They're born white, and they actually turn pink from what they eat. It's the pigments in the organisms that they consume. But there are some flamingos that don't turn pink. So were they genetically mutated for whatever reason? Or are they not, in multifactorial way, in a polygenic trait way, are they not eating the right organisms to turn pink? Okay, and that is the end of our lecture or this discussion on genes and genetic influences. Please bring all your questions with you to class. I will be going over some of these things in class. Thank you, and we'll talk soon. Bye-bye.